This is the problem from section 1.4, problem 7. You can pause this video and come back when you're done. Okay, this ODE seems to be looking exact. Why don't we check with the exact condition? dm over dy should be dn over dx to be exact. So this is m, this is n. So dm over dy is 2x tangent y, the differentiation tangent y is secant square from the integration table. And dn over dx is, since there is no x term in y, it's 0. Okay, so they're not the same, so it's not exact in this case. So let's assign the m term. Since it is not exact, let's assign p is 2x tangent y, and q is secant square y. Then from the exact check condition, this has to be with the integrating factor 0. This condition has to be met to be exact. So from here again, df over dy times p plus f times dp over dy equal this partial differentiation df over dx times q plus f times dq over dx. We know that this is too complicated, so we have to choose either a function of f or a function of y for the f. So let's choose to be function of x. Then df over dy becomes 0. We can simplify this term. We can get rid of the term, so the rest term is dp over dy is df over dxq plus f dq over dx. So dp dy, we have p and q here, so we can substitute those into here. So then f times dp dy is 2x secant squared y equal df. Since it's a function of x, we can make it total derivative times q is secant squared y plus f, and dq over dx is 0 because there's no x terms in q, so it's 0. So that's it. Now what? We have to make it separate, right? So we have to put all the df's to the left hand side and the rest terms to the right hand side. So df over f equal secant square cancels both sides, so 2x dx. Okay, it's not that horrible. Since it's separated, we have to do the integration on both sides. So f is x squared. So from here, simply writing e to the x squared. That's our integrating factor to make this equation to be exact. Now, since we obtained f, the integrating factor f, we have to check if it's really make it exact. All right, so now m has to be fp and n has to be fq. right? So m is 2x times e to the x squared times tangent y, and n is e to the x squared secant y squared. Okay, so the m over t, I'm sorry, let's move on to this space here. So dm over dy has to be dn over dx. So dm over dy is 2x e to the x squared secant y squared, and dn over dx is 2 times, right? dn over dx is 2 times x e to the x squared and secant squared y. Sorry for the mess here. Since they are the same, it is exact now. We are not done yet. We have to get the function u, a known function u, and it'll be the implicit, solution of y. So we have to get y to the end. But I'm not gonna do that here. Practice yourself. And I'm just writing the answer. So u is, final answer will be e to the x squared tangent y is c. Okay, that's our final answer should be. And of course, if you have initial conditions, then you could determine c, but we're not going to do that here.